Welcome back to the real number system. In this video, we're going to pick up in section 6.1. So let's get started. We begin this video thinking about simplifying fractions. A rational number is in simplest form, or sometimes called the lowest form, if the GCD, or greatest common divisor, of the numerator and the denominator is 1. In other words, the numerator and denominator can have no common factors other than 1. In example 3, our directions ask us to simplify or to write each of the following fractions in simplest form. In part A, we have 60 over 210. Now this fraction is not in simplest form because I noticed 10 is a common factor of both the numerator and the denominator. So divide the numerator and the denominator by 10. 60 divided by 10 is 6, and 210 divided by 10 is 21. Now I notice 6 and 21 have a common factor. 3 will divide into both 6 and 21. So divide the numerator and the denominator both by 3. 6 divided by 3 is 2, and 21 divided by 3 is 7. Look at part B. We have 156 divided by 48. These have a common factor of 2. They're both even numbers, so I know that 2 is a common factor. Divide the numerator and denominator by 2. 156 divided by 2 is 78. Use your scratch paper. And 48 divided by 2 is 24. Now 2 is also a common factor of 78 and 24. So divide the numerator and the denominator by 2. 78 divided by 2 is 39, and 24 divided by 2 is 12. 39 and 12 have a common factor of 3. So divide the numerator and the denominator by 3. 39 divided by 3 is 13, and 12 divided by 3 is 4. 13 and 4 have no common factors other than 1, and so this is our simplest form. Look at part C. Let's start with the 28 and the 42. These have a common factor of 7, so divide both the numerator and the denominator by 7. 28 divided by 7 is 4. Bring down the a and the b squared. 42 divided by 7 is 6, and bring down those variables. 4 and 6 have a common factor of 2, so divide the numerator and the denominator by 2. 4 divided by 2 is 2, bring down the a and the b squared. 6 divided by 2 is 3, and bring down the a squared and the b squared. Now notice I have a b squared on top and a b squared on bottom, so these cancel each other out. In the denominator, I'm going to rewrite a squared as a times a. An a in the numerator and an a in the denominator cancel each other out. So I have 2 over 3a for my simplified fraction. Now what if I want to know if fractions are equivalent? We have 3 different methods to show that fractions are equal. 1, we can simplify both fractions to the same simplest form. Our second method is to rewrite both fractions with the LCD. Or third, we can rewrite each fraction with a common denominator, but not necessarily the least. In example 4, we're going to use each of the methods that we just talked about to decide whether or not the fractions are equivalent. So let's look at our first method. The first method is we simplify our fractions. I have 12 over 42. Well, 6 is a common factor of both 12 and 42. 12 divided by 6 is 2, and 42 divided by 6 is 7. Let's look at the right side. 5 is a common factor of 10 and 35. 10 divided by 5 is 2, and 35 divided by 5 is 7. Notice I get the same thing on both sides of my equal sign, so these two fractions are equivalent. Now, let's look at the second method. The second method has us rewriting our fractions with the LCD. To me, the easiest way to find the LCD is to start with the largest denominator. So let's start with 42. I ask myself, does 35 divide into 42 evenly? The answer is no. So 42 is not the LCD. I look at the next multiple of 42. 42 times 2 is 84. 35 does not divide into 84 evenly, so 84 is not the LCD. The next multiple of 42 is 126. 42 times 3 is 126. 35 does not divide evenly into 126, so 126 is not the LCD. The next multiple of 42, 42 times 4 is 168. 35 does not divide evenly into 168, so that's not our LCD. The next multiple of 42 is 210, and 35 will divide into 210 evenly, so 210 is our LCD. I want to rewrite each of my fractions using that LCD. 42 times 5 makes 210 for the LCD. By the fundamental law of fractions, if I multiply the denominator by 5, I also have to multiply the numerator by 5. 12 times 5 is 60, and 42 times 5 is 210. Let's look at the right side. 35 times 6 makes 210. If I multiply the denominator by 6, then I also have to multiply the numerator by 6. 10 times 6 is 60, and 35 times 6 is 210. Notice again, I get the same fraction on either side of the equal sign, and so these are equivalent fractions. Now, let's look at our third method. The third method asks us to find a common denominator, but not necessarily the least. To find a common denominator, I can just multiply my two denominators together. So 42 times 35, I used my scratch paper and I got 1470. I want to rewrite my fractions with the common denominator of 1470. Times 35 will give me 1470 in the denominator. If I multiply the denominator by 35, then I also have to multiply the numerator by 35. Again, I use my scratch paper, and 12 times 35 is 420. 42 times 35 is 1470. Let's do something similar on the right side. 35 times 42 will give us an LCD of 1470. If I multiply the denominator by 42, then I have to multiply the numerator by 42 as well. 10 times 42 is 420, and 35 times 42 is 1470. Notice that the fractions are the same on both sides, and so we do have equivalent fractions. Look at part B. I want to use each of my three methods to decide if these two fractions are equivalent. The first method asks me to simplify my fractions. I need to find a common factor for 18 and 24. 6 is a common factor. 18 divided by 6 is 3, and 24 divided by 6 is 4. On the right side, 12 is a common factor for 12 and 36. 12 divided by 12 is 1, and 36 divided by 12 is 3. Notice that these two fractions are not equivalent. Let's look at the second method. The second method asks us to find our LCD. To find the LCD, I start with the largest denominator, which is 36. 24 does not divide into 36 evenly, so that is not my LCD. The next multiple of 36, in other words, 36 times 2, is 72. 24 does divide evenly into 72, and so my LCD here would be 72. we want to rewrite each fraction with a common denominator of 72. Well, 24 times 3 will give us that denominator of 72. If I multiply the denominator by 3, I also have to multiply the numerator by 3. 18 times 3 is 54, and 24 times 3 is 72. On the right side, 36 times 2 would make 72 in the denominator. If I multiply the denominator by 2, I also have to multiply the numerator by 2. 12 times 2 is 24, and 36 times 2 is 72. Notice again that these two fractions are not the same, and so our fractions are not equivalent. The third method asks us to find a common denominator, not necessarily the least. The easiest way to find a common denominator is to multiply the two denominators together. So 24 times 36, I used my scratch paper and that gave me 864. Rewrite your fractions with the common denominator of 864. 24 times 36 would give me 864 in the denominator. If I multiply the denominator by 36, I also have to multiply the numerator by 36. Once again, I use my scratch paper. 18 times 36 is 648, and 24 times 36 is 864. On the right side, 36 times 24 would make 864 in the denominator. If I multiply the denominator by 24, I also have to multiply the numerator by 24. 12 times 24 is 288, and 36 times 24 is 864. Notice that we do not get the same fraction on both sides of our equal sign, and so these two fractions are not equivalent. Let's suppose I tell you two fractions are equivalent. We have a over b equals c over d. A common denominator for these two would be multiplying the two denominators together, so b times d. I want to rewrite these fractions with that common denominator. The first fraction I have to multiply by d in the denominator, and if I multiply the denominator by d, I multiply the numerator by d. This gives us AD in the numerator of the first fraction and BD in the denominator. In the second fraction, I need to multiply the denominator by b, and if I multiply the denominator by b, I multiply the numerator by b. That gives us BD on bottom. Remember, the order that I multiply doesn't matter. And that gives us BC in the numerator. Notice here that my denominators are the same. And so we have AD and BC in the numerators. This brings us to our next theorem. Two fractions are equivalent if and only if AD equals BC. Now, you may have learned to cross multiply. However, I caution you about using the terms cross multiply. This is really not a math term, and it's often misapplied. Children need to have a basic understanding of fractions, so rather than teaching them to cross multiply, use one of the three methods that we used in the previous example. Let's talk about ordering our rational numbers. Well, if our denominators are the same, we can compare the numerators. And so if two fractions have the same denominator, then the fraction with the largest numerator is the larger fraction. But what if the denominators aren't the same? We have another property we can use. AD is greater than BC. So in example 5, we're asked to fill in the blanks with a greater than, a less than, or an equal to make our statement true. Now, I like to use a common denominator to compare my fractions. To find my common denominator in part A, I start with my larger denominator, which is 6. 4 does not divide into 6 evenly, so 6 is not the LCD. The next multiple of 6 is 12. 4 does divide into 12 evenly, and so 12 is my LCD. Rewrite each fraction with your LCD. Well, 4 times 3 would make 12 in the denominator. By the fundamental law of fractions, if I multiply the denominator by 3, I also have to multiply the numerator by 3. 3 times 3 is 9, and 4 times 3 is 12. I want to rewrite the second fraction with my LCD as well. 6 times 2 would make 12 in the denominator. And if I multiply by 2 in the denominator, then I need to multiply by 2 in the numerator. 5 times 2 is 10, and 6 times 2 is 12. Notice that my denominators are the same, so I can compare the numerators. 10 is the bigger numerator. So here, 10 over 12 is the greater fraction. Remember, our than or greater than sign will always open to the bigger number. In other words, the alligator is always going to open its mouth to eat the bigger number. So here, 9/12 is less than 10/12, or 3/4 is less than 5/6. Look at part B. We are comparing 9/4 and 2. Well, 2 is understood to be 2 over 1. I need to find my LCD, so I start with my larger denominator, which is 4. 1 does divide into 4, so 4 is my LCD. Since 9 over 4 already is written with the LCD, I'm just going to bring that fraction down. However, I need to rewrite 2 over 1 with my LCD. 1 times 4 would make 4 in the denominator. If I multiply the denominator by 4, I also need to multiply the numerator by 4. Again, just bring down that first fraction. 2 times 4 is 8 in the numerator, and 1 times 4 is 4 in the denominator. Now that my denominators are the same, I compare the numerators. 9 is bigger than 8, so 9 over 4 is bigger than 8 over 4. That tells me that 9/4 is greater than 2. Let's look at one more example with the less than, greater than, or equal. First, I need to find my LCD. My larger denominator is 10. 5 does divide into 10 evenly, so 10 is my LCD. The first fraction already has a denominator of 10, so just bring it down. I need to rewrite the second fraction with that denominator of 10. 5 times 2 would make 10 in the denominator. If I multiply the bottom of a fraction by 2, I also multiply the top by 2. Bring down the first fraction. 3 times 2 is 6 in the numerator, and 5 times 2 is 10 in the denominator. Now that my denominators are the same, I can compare the numerators. 6 is the bigger numerator. And so here, the alligator opens its mouth to eat the bigger number, and so 4/10 is less than 6/10, or 4/10 is less than 3/5. That brings us to our final topic in section 6.1. If you give me any two rational numbers, I can always find a rational number between those two numbers. Now, one way to do this is to add the numerators and add the denominators, and that will always give you a fraction in between the two rational numbers. However, again, I like to work with my LCDs. In example 6, we're asked to find two fractions between each pair. First, I'm going to find my LCD, so I start with the bigger denominator, which is 18. 2 does divide into 18 evenly, and so 18 is my LCD. Bring down your first fraction and rewrite the second fraction with a denominator of 18. Well, 2 times 9 would make 18 in the denominator. If I multiply the denominator by 9, I also need to multiply the numerator by 9. And 1 times 9 is 9. 8 is between 7 and 9. So 8 over 18 would be between my two fractions. That is one fraction. However, my directions ask me to find two fractions. So to find two fractions, I'm going to double my denominators. If I double my denominators, I also need to double the numerators. 7 times 2 is 14, and 18 times 2 is 36. 9 times 2 is 18, and 18 times 2 is 36. Now I can find two fractions between 14 over 36 and 18 over 36. 15 over 36 would be between those two, as well as 16 over 36. Always simplify your fractions. 3 goes into 15 5 times, and 3 goes into 36 12 times. 16 and 36 have a common factor of 4. 16 divided by 4 is 4, and 36 divided by 4 is 9. So 5/12 and 4/9 would be between my two given fractions. Let's look at one more example. Again, we're asked to find two fractions between each of the fractions that were given. Find your LCD. Start with your larger denominator, which is 5. 4 does not divide into 5 evenly, so 5 is not my LCD. The next multiple of 5 is 10. 4 does not divide into 10 evenly, so I move to the next multiple of 5, which is 15. 4 does not divide into 15 evenly, so I move to the next multiple of 5, which is 20. And 4 does divide into 20 evenly, and so 20 is our LCD. Rewrite each of your fractions with your LCD. 4 times 5 would make 20 in the denominator. If we multiply the denominator by 5, we also multiply the numerator by 5. And 5 times 3 would be 15. For the right fraction, 5 times 4 would make 20 in the denominator. If we multiply the denominator by 4, we also multiply the numerator by 4. And 4 times 4 is 16. Now, I don't have a whole number between 15 and 16. Just like I did in the previous example, I'm going to double the denominators. And if I double the denominators, I also have to double the numerators. 15 times 2 is 30, and 20 times 2 is 40. In the second fraction, 16 times 2 is 32, and 20 times 2 is 40. I do have a fraction in between these two. 31 over 40 would be between my two given fractions. But notice my directions ask me to find two fractions. So I'm going to double denominators again. And if I double the denominators, I also have to double the numerators. 30 times 2 is 60, and 40 times 2 is 80. 32 times 2 is 64, and 40 times 2 is 80. Now I can find two fractions between my given two fractions. 61 over 80 would be between my two fractions, as well as 62 over 80. Always simplify your fractions. 61 over 80 doesn't simplify. However, 62 and 80 have a common factor of 2. 62 divided by 2 is 31, and 80 divided by 2 is 40. So two fractions in between my given fractions would be 61 over 80 and 31 over 40.